Hello students, in the last video we began to talk about how to graph rational functions by starting with the vertical asymptotes. In part 2 today we are going to talk about the horizontal asymptotes. We're going to be using the same examples that we used in part 1. So if you have your packet out and the guided notes ready to go, you'll be able to fill in the horizontal asymptotes as we go along. Now for horizontal asymptotes there are three different types of rational functions, and how we decide what the horizontal asymptote depends on the type. One case happens when the degree in the numerator is less than the degree in the denominator. And this one's a pretty easy one because whenever you notice that the degree in the top is less than the degree in the bottom, your horizontal asymptote is always going to be y equals 0. Your horizontal asymptote is always going to be y equals 0. So there's no math to do there. You just have to recognize the degree in the top is less than the degree in the bottom. The second case happens when the degree in the numerator is exactly the same as the degree in the denominator. And when this happens, you take the leading coefficient. Remember, the leading coefficients are the numbers in front of the variable with the biggest exponent. In this example here, I have a degree of 1 on the top and a degree of 1 on the bottom. Since they are the same, I would divide the leading coefficients, 6 divided by 2, to get y equals 3 as my horizontal asymptote. The final case, as you probably could predict, is what to do when the degree in the numerator is greater than the degree in the denominator. And when this happens, there is no horizontal asymptote. So if you notice this, you just say no horizontal asymptote and move on to the next question. So let's look at some examples. In our first example here, we have 3x minus 4 over x minus 2. We're looking for the horizontal asymptote. I'm just going to write HA for that. Okay. So for the horizontal asymptote, since the degree in the top, which is 1, is the same as the degree in the bottom, which is also 1, that means that we divide the leading coefficients. Remember, the leading coefficients are the numbers that are in front of those variables with the largest exponent. So in this case, our horizontal asymptote is going to be 3 divided by 1, which is just 3. So our horizontal asymptote is y equals 3. When you're graphing this, you're going to go to the y-axis, and through 3 on the y-axis, you're going to add in that left to right asymptote. In our second example, we have a degree of 0. So when there's a constant term, the degree is essentially 0. And in the denominator, we have a degree of 2. So the degree in the top, in the numerator, 0, is less than the degree in the denominator, which is 2. Well, when that happens, our horizontal asymptote is always the same. It's y equals 0. That is the same as the x-axis because that has a y value of 0. Remember, we sketch these asymptotes with dashed lines, and these are going to be left to right. In our third example, we have a degree of 2 in the top, in the numerator, a degree of 2 in the bottom, in the denominator. Remember, those degrees come from the biggest exponent. Since those are equal, we take the leading coefficients, which are 1 and 1, and we divide them. Leading coefficient in the top divided by leading coefficient in the bottom. So the horizontal asymptote here is y equals 1. So through 1 on the y-axis, we'll go left to right. Get that horizontal asymptote in there. I'm going to go back to the last example really quickly and add in that horizontal asymptote here of y equals 0. And we'll go on to example 4. Now, let's pause here really quickly. I want to be kind of clear about something that we're going to have to talk about again later, but that is the difference between a vertical asymptote and a horizontal asymptote. Vertical asymptotes cannot be crossed ever. If you have a vertical asymptote on your graph, your function should not go through it. It's not going to happen. It is undefined there and can't happen. Horizontal asymptotes are usually not going to be crossed. They're usually going to be a place on the graph where the function does not cross, but in some cases they're more of a suggestion for the graph, and it will sometimes, you'll notice as you're practicing, it will sometimes cross the horizontal asymptote. If that happens, it's probably okay. If you have a question while you're working, stop me and I'll look at it to make sure that it's good for the question you're working. But consider this to be an asymptote that shouldn't be crossed, but that every once in a while the function might still cross it. All right, so the horizontal asymptote in example 4, we have a degree of 1 in the numerator, a degree of 1 in the denominator. Since they are the same, we've got degree equal degree. That means we divide the leading coefficients. 5 divided by 1 is 5, so our horizontal asymptote here is going to be y equals 5. And again, we'll get that on our graph through 5 on the y-axis. Again, it's a good idea to add these in a different color than you're going to use to actually graph your function, so they kind of pop out. It's good to use a kind of brightly colored pen or something, and it kind of helps you frame your graph and know where things are going to happen. All right, fifth example. We have a degree of 0 in the numerator. Remember that anytime the numerator does not have a variable, the degree is 0. And in the denominator, we have a degree of 2. Well, 0 is less than 2, which means that the horizontal asymptote is going to be y equals 0. There's no other choice. That always happens. So we'll go through 1, 2, 3. There we go. We're going to add those. Okay, so for example 6, our degree in the top is again 0. In the bottom, we have a degree of 1 because x to the first power is understood to have a 1 there. 0 is less than 1, which means our horizontal asymptote is going to be y equals 0. So we will throw it up on the graph. And remember, in the last video, we had an extra example. We're still going to use this extra example. Here, degree of 2 is equal to the degree of the denominator. So since they are equal, we use the leading coefficient. In this case, it's 1 divided by 1. So y equals 1 over 1, which is equal to 1. So the horizontal asymptote is going to go through y equals 1, and we'll add that up to the graph. So we've almost got, in all of our examples so far, all of the asymptotes kind of filled in. We're going to talk about another type of asymptote in a later video. But in these first two cases, we have vertical asymptotes and horizontal asymptotes, and we've talked about how to find them now. I want to add another extra example. So wherever you put this example in your notebook, let's add one more in. So here's our next example. We've got x squared minus 2x minus 15 over x minus 5. I want to go back with you in time and review how we found the vertical asymptote so that we can kind of remember that. Remember, the first thing we do is factor the top and the bottom if we can. So the top of this function factors to become x minus 5 times x plus 3. Because x times x is x squared, negative 5 times 3 is negative 15, and negative 5x plus 3x is negative 2x. So that's what that factors to. And in the denominator, we have x minus 5. Remember, we are simplifying this, so since there's an x minus 5 on the top and the bottom, they cancel out. We'll come up here, and all we're left with is x plus 3, right? So everything canceled out. Well, in this case, there is nothing left in the denominator. So do we have a vertical asymptote? Well, no. In the final form, there is no denominator. There's no variable in the denominator, so we're not going to end up with a vertical asymptote in this case. For the horizontal asymptote, we're supposed to check the degree in the top. Starting off is 2, so we're on horizontal asymptote here. So the degree in the top is 2, and 2 is greater than 1, the degree in the denominator. Well, remember, this is the type of problem where there is no horizontal asymptote. There's 3 types. If the degree in the numerator is less than the degree in the denominator, it's y equals 0. If the degree in the numerator is equal to the degree in the denominator, it's going to be the leading coefficient of the top divided by the leading coefficient of the bottom. But when the degree in the numerator is greater than the degree of the denominator, you do not have a horizontal asymptote. Something else is going on there. Okay, so this is a kind of a special example where we started with a rational function, But through some reducing, we ended up with something that's no longer rational, that does not have these types of asymptotes. All right, so that is it for today. I'm going to recommend that you, after this video, go through the practice problems for 4C.1 and 4C.2 and go ahead and check those degrees, add in any horizontal asymptotes that you can find, and then check out the next video, which is also 4C.1 Part 3, and it's going to be about a new topic called How to Find Holes. Very exciting. Please see me if you have any questions, and I will see you in class.